This is PreCalc 11, Chapter 3.5. This time we're going to learn about the discriminant. And the discriminant is what's inside the radical. It's the radicand of the quadratic formula. And the discriminant can be used to determine the nature of the roots. If the discriminant is positive, that means there's two real roots, because we can take the plus or minus of something. The plus gives us one answer, the negative gives us an answer. If the discriminant is equal to 0, we just have one real root, because if we have plus or minus square root 0, that's just plus or minus 0. Adding 0 isn't going to change our positive answer or our negative answer, so that's why we only have one real root. Lastly, if the discriminant is negative, there's no real roots. Remember, it's imaginary. Another thing that you can tell from the discriminant is, if it's a perfect square, that means we can take the square root of it as an integer. And that means the equation can be solved by factoring. If it's not a perfect square, then we're going to get radicals in the solution. You're best off just using the quadratic formula to find your solution. How many roots does this quadratic have? Well, let's figure out our a equals 3, b equals -5, c equals 10. So b squared minus 4ac equals -5 squared minus 4 times 3 times 10. 25 minus 120. This is less than 0. We can tell because 120 is bigger than 25. So we just say no real roots. We're not asked to figure out what the determinant is, so we don't need to evaluate it. I've already mentioned this, but that's why we say no real roots rather than no solution. Okay, for a harder problem, determine k so that there's only one real root in the equation. Well, how do we know when there's one real root? Well, we have this, the discriminant equals 0. So we just use that. A equals k. B equals 6, C equals -4. So b squared minus 4ac equals 0. 6 squared minus 4 times k times c, which is -4. So we have 36. -4 times -4 is positive 16k. Move the 36 over to the other side. We have -36. Divide both sides by 16. We have -36 over 16. So that's k. We can also reduce this. There's a common factor of 4, so -9 over 4. When you're not sure, always look up your definitions. Couple more problems. Determine k so that there are no real roots in this equation. Again, a equals -2, b equals 7, c equals 2. So b squared minus 4ac is less than 0. Again, no real roots. B squared minus 4ac is less than 0. Substitute our known values. 7 squared minus 4, -2. C is 2k, so right? 2k is less than 0. So we have 49 we have negative 4 times negative 2 times 2. Again, this is positive 16k, less than 0. Move this to the other side. We have 16k is less than negative 49. K is less than minus 49 over 16. This can't be reduced, so that's our final answer. Last example. Determine a k such that the following equation has two rational real roots. A equals 3, B equals 8, C equals negative k. Okay, we're only looking for one k, and we have b squared minus 4ac equals perfect square. And substitute our known values. 8 squared minus 4 times 3 times negative k. Perfect square. Just pick any perfect square. 16. Okay, so we have 64 minus, and it's actually a plus because we have two negative signs. 4 times 3 is 12k. So 12k equals 16 minus 64 is negative 48. K, divide both sides by 12, we have negative 4. So that's one solution. If you substitute a different perfect square, you get a different solution. This perfect square should be a positive perfect square. If you want to be fancy, you could also use something like 9 over 4. And that completes this lesson.